Hi everyone, my name's Jorin, one of the vets at the SEAL office, and today we're going to be talking about economic inequality. How to distribute wealth or income is a recurring social problem, and more than 100 years ago, Italian sociologist Corrado Gini came up with a statistical measure of inequality, which is now known as the Gini coefficient. We're going to take a look at this coefficient, what it means, how to interpret it, and how we can represent it visually.
To think about what the coefficient is and why it's important, let's take a simple example. Imagine there's a club of really dedicated English speakers on Lingnan campus, the Lingnan English Group, or LEG. Now let's say that LEG has 10 members, a small group, but passionate. In fact, they're so interested in English that they receive a grant from the university to buy materials for studying English. The grant is 10,000 Hong Kong dollars. Now, how should the group divide up the grant? Well, if the group was to be completely fair, they would divide the reward equally between each of the members. Each of the 10 club members would get a tenth of the reward, or $1,000. Completely fair. Everyone's happy. Okay, now let's expand this. Imagine that every other university has an English learning society as well, and somehow they all happen to have exactly 10 members and get the same grant. I know it's a bit hard to believe, but in the world of English, anything is possible. These groups, however, might decide to divide up the grant in different ways. Let's look at another English learning society, one not as fair-minded as the previous group. The group's president decides to keep the entire grant for themselves, so they're really happy, and the rest of the group members, not so much. This is the most unevenly you could distribute the grant. These groups represent two extremes, but there are a lot of other English learning societies that probably have different distributions in between them. Let's take one more example group. This group has a very particular set of rules, including one that says anyone who has been a member for fewer than 6 months is not eligible to receive any rewards or grants that the group might receive. In this group, 5 out of 10 members are new, and thus ineligible under this rule. Consequently, the grant is divided up evenly. Half of the group members split the 10,000 between them, and the other half gets nothing. How does this method compare to the other two? Well, they're certainly not dividing it completely fairly, given that only half of the members receive any kind of reward. On the other hand, it's not completely unfair either. 5 of the members get part of the reward instead of just 1. But this kind of analysis seems a bit abstract. Is there any way we can objectively measure the differences in how equally or unequally the grant is divided between these three groups? Well, first off, always trying to compare straight numbers is hard. 10 members is manageable, but what if we were talking about an entire university or a whole city? We might quickly get caught up in specific numbers and miss the big picture. Instead, let's try to think about our groups in terms of percents. What percentage of the population controls what percentage of the grant? This allows us to do a kind of comparison, no matter how big the groups might be. Let's try this to compare our three groups. First, let's split the groups into 10 slices, each slice being one person and representing 10% of the total number of members. Now, let's look at the first group. Since the amount of money is split evenly between the members, each 10% of the population gets 10% of the overall income. That's a completely even ratio. Now, the second group, well, one person took all the money, so 10% of the population, the top 10%, took 100% of the money. Finally, the third group, 5 people took all the money, so 50% of the population took 100% of the income. Now let's try to compare these groups using a single measure somehow. Since we're concerned about inequality, let's take the percentage of the population that controls the most income and then compare those two percentages. So working backwards, 50% of the third group controls 100% of the income. So 1 minus 0.5 is 0.5. For the second group, 10% of the population controls 100% of the grant, so 1 minus 0.1 is 0.9. And for the third group, it's completely even, so the top 10% takes 10% of the income like everyone else, giving a result of 0. So what did we just do here? Well, by comparing the percentages of population with the money in the group, we came up with a single number measure for each group that seems to tell us something about how equally the money was divided. The higher the number, the more unequal the group is, and the lower the number, the more equal it is.
So why go through this whole exercise? Well, the questions we asked, how to measure the inequality within a particular group, and how to compare the degree of inequality with other groups, is precisely the same kind of questions that social scientists and economists ask themselves constantly about our society. Each country also has a total population and a certain amount of money, income or wealth, depending on how you want to measure it. But if you just look at how large a country's economy and population is, that doesn't really tell you everything valuable. We also care about how that wealth is divided among the population. If it's really unequal, then that can make people unhappy. Whereas a country with a smaller economy, but with less inequality, may end up being happier. To try and measure this, researchers use the Gini coefficient, which, like the exercise we just went through, comes up with a single number to represent the equality or inequality with which income is divided among a population. And, similarly, it looks at the percentiles or percentages of income and population to calculate that number. This number is a ratio, comparing how wealth or income is actually distributed in society to if it was distributing perfectly. The coefficient can take on values of 0 or 1, or any value in between, as we have seen. Remember our little English clubs. If the coefficient is 0, that represents perfect equality. Everyone has the same amount of money. If it's 1, that means one person controls all the money in the economy. But those are extreme cases. Gini coefficients will almost always fall in between 0 and 1, and the higher the number, the more income is distributed unequally in that society. Let's take a look at the Gini coefficient measures of some countries to get a sense for which societies get lower or higher coefficients, like our previous example of clubs.
As we can see from the table, Hong Kong ranks 9th on the Gini index with a Gini coefficient of 0.539, which means that the distribution of family income in Hong Kong is not very equal, especially compared to other countries. So that's Hong Kong's Gini coefficient. But it's a bit harder to understand how a coefficient is calculated for an entire country instead of one 10-person club. Let's take a deeper look. It's easier to understand the Gini coefficient if we look at it visually. Each coefficient is actually calculated from a cumulative distribution graph. Let's construct this graph step by step. First, a cumulative distribution graph means that instead of specific numbers, we're looking at percentiles, like we did with the English clubs. Here, we're just representing those percentages visually. The first axis here is the x-axis and represents the population we're looking at. This 10 here refers to 10%. This represents the bottom 10% of our population. Next, 50 means half of the population, and this keeps increasing until we reach the corner of our graph representing 100% of the population. The y-axis represents income percentiles and works in a similar fashion. The first 10 represents 10% of the economy's total income or wealth and increases all the way to 100% of income. Now that we better understand the graph, let's look at what a particular point on the graph means. If we look at this 50% mark in the population and trace it up to this line, then come over here, we can see that that's the 50% mark in the income as well. That means half of the population controls half of the income. Any other percentile here will find an exact match on the other axis representing perfect distribution of income. That's why this line here that connects the endpoints of the two axes is known as the line of perfect equality. But this is an ideal scenario. Let's now introduce the element of the graph that represents unequal distribution, the Lorenz curve. This curve changes our calculations. Now, if we trace over the 50% population mark to the curve and bring it across, we don't get 50% income, but more like 25. That tells us that the bottom half of the population controls 25% of the economy's income instead of half. That means the top half controls the other 75% of the income. That's much less equal, right? That's the function of this curve. We don't need to worry about how exactly to calculate this curve, but just try to understand it intuitively. The more the line curves out, the more unequally the income is distributed. The curve splits the area under the line of perfect equality into two sections, A and B. The area above the curve, A, roughly represents the inequality in how the income is divided. The further the Lorenz curve comes out, the bigger A is and the more inequality there is in the society. The actual Gini coefficient is calculated by taking A and dividing it by A plus B, which represents the total area under the line of perfect equality. Like we said before, the coefficient is a ratio between how income is actually distributed and how it could be distributed in a perfectly equal society. The result is some fraction. Getting that exact calculation is tricky, but here's a good rough measurement you can use instead. Take any percentage of the society that you want, like the top 20%, and then trace it up to the curve and across to the income. Subtract the population percentage from the income percentage, and you'll get a rough Gini coefficient measure. For instance, if 20% of the population controls 70% of the income, then the Gini coefficient is 0.7 minus 0.2, or 0.5. This Gini coefficient will always be smaller than the actual Gini coefficient because it doesn't capture as much of the area under the Lorentz curve, but it's really useful in understanding the principle behind the coefficient.
So now we have a better understanding of how the Gini coefficient works. But how useful is it as a measure of inequality? Well, for one, it's pretty simple. You always get one number for each time period that you calculate it for, and you can compare it across time or across countries. There is even a global Gini coefficient measuring total inequality across all countries. This makes it a handy indicator that's often used by social scientists, economists, and organizations such as the United Nations for measuring inequality. The Gini coefficient also helps you get a better picture of a country's overall economic development. If the economy is growing, that's great. But the most common measure of economic growth, gross domestic product, or GDP, is often criticized for ignoring how that growth is spread out among the people. If growth is increasing, but so is the Gini coefficient, then that tells you that new economic growth is not benefiting everyone equally. On the other hand, this coefficient can be a bit difficult to understand intuitively. We see the number go up or go down, but what does the number mean exactly? It's still a bit of an abstract measure. However, we've gone through how the coefficient is calculated, and hopefully this has given you more insight into the Gini coefficient, how it's used, and why it's important. Just like our English learning societies at the beginning of this video, countries are groups that also need to think about how their wealth should be divided amongst the population. And people who study countries often use this number to try and better understand and compare the different ways in which countries do this. Now you too can look at the Gini coefficients and their accompanying graphs and have a good idea of what it means and the significance of that coefficient increasing or decreasing as a society continues to progress. That's all for now. I hope this was useful, and the best of luck to you in your studies.